All right, and we are live on in everyone. Robert the AP Math Guy, and tonight we're going to be we're almost gonna finish up Calculus 1 tonight. The only topic we have left is optimization, which, as you notice, we're gonna do in multiple parts. So we're gonna do some tonight, and we're gonna do some more optimization tomorrow. So with that, let's go ahead and hit that heart button. Hopefully everyone's had a good today's Friday. Yeah, good Friday evening. No, I have. Go ahead and see if I can't get this glue stick open or glue bottle open. Also, I'm going to go ahead and hit the button that lets me wave at people. But in case I can't hit the button, I'll go ahead and wave at you now. Hi, everyone. So, yeah. Hey, Joseph, how's it going? Welcome on in. Welcome on in. How's it going? You're ready for a new lesson? Awesome! Well, hopefully, I am ready to give you a new lesson. Yeah, so welcome on in, everyone. As you're joining in, be sure to hit that heart button. Yeah, we're going to actually be going over a few of them tonight, Supa. I have, so tonight we're going to go over area and we're going to do defense problems. Tomorrow, we're going to be doing other types of optimization problems. But yeah, so how's it going? Can you also cover related rates and deriving shape areas slash surface areas? So, I already did a live on related rates. Actually, I did 3 of them. All of them you can find here. Hey, Brandsy, how's it going? But yeah, so as far as deriving shape areas or surface areas, tonight we're just gonna go into Yep, yes I did. And you can find that live here. But what I might do is I might do a couple of things here on TikTok to remind everyone how to what's next after optimization. So tonight and tomorrow we're doing optimization, and then that is the end of Calc 1. So what I'm going to do is Sunday, I'm trying to figure out whether I want to. There are a couple algebra things that I want to do, and so I might cross one of those off the list, and then we're going to jump into algebra. We're going to jump into calculus 2 by talking about these things called Riemann sums. So that is where we are headed. Can I do challenging problems? Well, some people actually find optimization to be one of the most difficult concepts in Calc 1. So, I don't know if that answers your question or not, Joseph, but we are going to do some problems tonight. Thank you, Camel, for the follow. You did Riemann in Calc 1? Okay. Yeah, so when I learned it, we did it in Calc 2, so that's what I'm going off of. But if you did it in Calc 1, then that's great. Cool. Awesome. So with that, you loved calculus. I'm glad to hear that, Kanan. I'm really happy to hear that. So yeah, let's go ahead and get this show on the road. Can I integrate x to the x? I can, but I'm focusing on optimization tonight. Actually, can we integrate x to the x? I have to look at that one again. I would have to look at that one again. Cool. All right, so let's talk about optimization. So how do we solve? So let's actually start with a problem. So I'm getting my glue. For some reason I can't find my glue stick. That's okay because I have the why isn't this? It's open, isn't it? No, that's why. That is why I can't glue open because there's a little cap on it, preventing me from opening this. Oh, awesome! Let's go! Thank you all for the 1K likes. As I'm sitting here struggling to. Oh, I know, right? They definitely can be evil. Especially when you need them to open. For some reason, this one is not opening. There we go. There we go. The safety cap is off. So let me go ahead and try to get the glue working now. Oh yeah, there we go. As I learned the last time I used this, a little bit of glue goes a long way. There we go. All right. Question 1. Find two positive numbers such that their product is 192 and the sum of the first plus 3 times the second is a minimum. All right, so how do we solve a problem like this? So first, let me actually get a note card. Believe it or not, I think this is my last note card. So solving how to solve optimization problems. Because optimization like related rates is something a lot of students struggle with, And we have and we have to break it down. So first, you have to write down any relevant formulas. So here, we're asked to find the two positive numbers such that their product is 192. So, what can I say? Well, we know that they're two positive numbers. Let's call one x and the other y. So I know, what do I know? I know their product is 192. So x times y is going to be 192. And then we also know that the sum of the first plus 3 times the second is a minimum. So we're asked x plus, right, because sum of the first plus 3 times the second, so that's going to be x plus 3y, and we want that to be a minimum. So that is the formula we are given. So we want that to be a minimum. So here, I don't know about you, but what I want to do is I only want to take the derivative with one variable in mind. So step 2 is to reduce to one variable if necessary, because sometimes we do not need to, I forget, it's necessary 1c or 2c. I think it's 2c's. NECCE, only one. Thank you. 2 S's but 1 C. There we go. So sometimes we're going to already have it in one variable, so we don't have to reduce it. However, I want to reduce that down to one variable. So I have two variables here, and I want to solve this first equation so that I can plug into one of these two variables. I'm going to solve for y. So to solve for y, I'm going to go ahead, because I'm multiplying x by y, I'm going to divide both sides by 192. So I'm going to put my scratch work here. So xy equals 192. Divide both sides by by x. And I get y is equal to 192 divided by x. So now from here, I'm going to take this and I'm going to plug it into my formula. So I have x plus 3 times 192 divided by x. And we're going to say that equals, let's say it equals m for minimum. So from here, I'm just going to simplify. So I have 3 times 192. That gives me what? X plus 3 times 192. So that's 6, 7, 5. Nope. 526 over x. Nope, it's 576. What am I doing? 576 over x is equal to m. So now that I have reduced to one variable, now step 3 is to take the derivative. Take derivative of our function, of our relevant function. So here, the function that I want to take the derivative of, since I'm finding the minimum, is going to be this function here. So, thank you, Math Tutor, for the heart me. Thank you, Camel. So now, I'm going to rewrite 576 over x as x plus 576 times x to the negative first. And that's going to equal m. That's right, Joseph. So I'm going to take the derivative, and then I'm going to set it equal to 0. So, let me zoom in a little bit. There we go. All right, so now, what is the derivative of that function? Yep. So m of x will be m prime. But what about the other side? Joseph says 1 minus 576 over x squared. Or x in negative second. Right, so, remember, variable without an exponent is the same as x to the first. And also remember, how do I take the derivative of this? Well, I simply use power rule. And what does power rule say? Power rule says if I have x to the n, its derivative, I take the exponent, move it out front, multiply by whatever coefficient's in front, and subtract 1 from the exponent. So I have x to the first, so I have 1, move it over, so I have 1 times x to the 1 minus 1. Well, x to the 1 minus 1 is 0, and x to the 0 is 1. So this is the same as saying 1 times 1. And then I'm going to do the same thing here. I take my negative 1, move it out front, multiply it by 576, and I have x to the negative second. So I'm going to rewrite that as the following. There we go. M prime of x is equal to 1 minus 576 over x squared. So now, as Joseph said, I'm going to set the derivative equal to 0. So I have 0 is equal to 1 minus 576 over x squared. So from here, what I can do is I'll subtract 1 from both sides. So I get negative 1 is equal to negative 576 over x squared. And then I'm going to get rid of that negative sign. So I'm going to multiply the negative out. So I have 1 equals 576 over x squared. So anything divided by itself is 1. So I'm going to multiply both sides by x squared. So I get x squared is equal to 576. And now I want to take the square root of both sides. And if I did this right, which I'm more than sure I did, I plug in the square root of 576, excuse me, that should be 24. Yep. So, here, x equals 24. Now, normally, it would be plus minus. However, remember at the beginning, we said that x and y are positive. So I don't actually have to have I actually don't need the negative square root here, because we were given earlier that x and y are both positive. So now, thank you, Joseph. So yeah, so now what I'm going to do, I'll go ahead and plug in this 24. I don't know about you. I find this to be an I'm going to go ahead and plug it in here. So I have 24. 24y is equal to 192. How do I remember all of this? So I've been doing this for a while, but it's just a matter of practice. Equal to 0. I forgot to write that down. Sorry about that. And solve. Oh, I'm not sure about that. I am not sure about that, Joseph. So yeah, if 24y is equal to 192, what would y be equal to? Yeah, I'm not that. I promise you it is not that. Joseph said y is 192 over 24. Can you simplify that? What would y equal? Joseph said 8. That's right. So if I divide both sides by 24, I get y is equal to 8. Hey, Grandes, how's it going? Yeah, so here I have x is 24, y is 8. Now, how do we know that that's a minimum? So, here's where step 5 comes in. What we're going to do is we're going to take the second derivative of our original function. So, we're going to take the second derivative, and we're going to check its sign. Take second derivative and check sign. Thank you, Ali Boo, for the follow. So let's go ahead and take that second derivative. So here's my first derivative. Remember, the second derivative is just the derivative of my derivative. So what would be the derivative of 1 minus 576 times x in a negative second? So m double prime of x. Well, again, here, 1 is a constant. Well, how do I know it's a constant? It's a constant because there's no variable next to it. So, because I have a constant, its derivative is going to be 0. So the derivative of 1 is 0. And then, like I did before, I'm going to use power rule to find the derivative, of negative 576 times x in a negative second. So I'm going to take my negative 2, move it out front, and multiply by 576. Or negative 576, rather. So this is 500... So negative 576 times negative 2. What's that going to give me? It's going to give me 2, 5, 11. So 1152 times x to the negative 2 minus 1 gives me negative 3. I think that multiplication is right. I'll quickly check that. So 576 times 2. Thank you, Isaiah, for the follow. 6 times 2 is 2. Carry the 1. 7 times 2 is 14. Plus 1 is 15. 5 times 2 is 10. Plus 1 is 11. Perfect. Awesome. Thank you, Joseph. So here, now I said I need to check its sign. So what I'm going to do is I'm going to plug in my critical point of x equals 24. And I'm going to plug it into this function. I don't care about its value. All I care about is its sign. So if second derivative, if second derivative is positive, then we have a minimum. And if f of x, if second derivative is negative, if the second derivative is negative, then it's a maximum. So what I'm going to do is I'm going to plug in 24 here. And so, can I show this as a graph? Yep, in a moment. So, I can rewrite that as, so m double prime of 24 is equal to 1,152 over 24 cubed. Now, a positive number cubed is positive, and positive divided by positive is going to give me positive. Just for fun, though, let's see what that actually equals. So, 1152 divided by 24 cubed is going to give me approximately 0.083 repeating. Actually, no, that would be equals. So last time I checked, this is a positive number, so this is a minimum. Cool. Any questions so far? And yes, I am going to bring it up as a graph. So, xy equals 192. And x plus 3y equals, or actually that's a minimum. So here is the graph of xy equals 192. So what do we see here? We notice that we have a So that's the graph of that, and then we wanted to minimize x plus 3y. Huh. What am I missing? Good on you for doing this stuff, man. I still can't derive joy from it. Ooh. Okay, Aaron. I'm sorry to hear that. Plug in x plus 3y only. Yeah, but it's gonna want a value that it's equal to. Like your channels. Thank you, MT. Thank you for that. I appreciate that. Yeah, so when I try to plug in x plus 3y, if we remember, it's not exactly, we didn't have it equal to anything. So in order for me to graph it, I'd have to set it equal to something. Bro, I got a 100 on my Unit 1 test. You're welcome, Bones. Congratulations. That's awesome, man. You know what that means? How about just graph? Yeah, we can do that. So, second derivative, for first derivative, so second derivative would be x, no, yeah, 576, no, 1152 divided by x cubed equals y. Oh, I see what's happening. I pressed the wrong button there. Thought I pressed that. There we go. So this is the second graph of the second derivative. So that is the graph of the second derivative. If I graph the first derivative, it would be 1 minus 576 over x squared. So the minimum, so here, so when we take a look at the first derivative, my zeros are where my critical points are. So that's, and because on the graph of the first derivative, anything below the x-axis means the slope is negative, and anything above the x-axis, the slope is positive. It's kind of hard to see, but there is your minimum. And then, if we look on the other side, we have another minimum here at negative 24. But remember the condition that we had earlier in that our number had to be positive. So this is an extraneous minimum. But yeah, so Bones, congratulations again on your test. But you know what that means, right? You know what happens when you get a 100 on your test and you do really well? You know what happens? You get a high five. All right, so on 3, I'm going to give you a high five, Bones. And everyone else, if you want to give Bones a high five as well for his test, feel free to join me. Ready? 1, 2, 3. Oops. There you go. Congratulations. Can you provide real world examples of use? Well, we're actually going to get there in a few minutes, Gizmo. In fact, optimization is going to show real world situations. It means you got to deposit money into his account. Yes, Joseph. Oh, yes, that's a good one. Yeah. So cool. Any questions on this problem? I'm going to go ahead. Actually, I don't know if I have enough room for the next problem. So what I'm going to do is I'm going to go ahead and turn the page. There was a back of the page that I thought I was going to use the other night, but I didn't. So we're going to use it tonight. How does that problem help me predict the stock market price? Well, that problem in particular won't, because it deals with maximizing or minimizing the area of or not the area, um but optimization can help you with not necessarily predicting the price of the stock market. And when we talk about the stock market, I think you mean the the stuff like the S&P 500 and stuff like that. But is a minimum for the second derivative mean it will concave up? Yep. A minimum. So a minimum of a first derivative means it's concave up. Yes. So minimums, remember. So minimums are going to look something like this on the graph of F. And a maximum is going to look something like this. Won't they all concave up if it's min for a second derivative? All right, let me read that again. Won't they all concave up if it's min for second derivative? So if you're talking about the minimum of a function, then yes, it's going to be concave up. Minimums are always concave up. Maximums are always concave down. So f double prime of x is greater than 0 here. F double prime of x is less than 0 here. So yeah, let's go ahead and try another problem. This time I don't have to fight with the glue. Like I said, if there's one thing I've learned from using this glue the last time, it's that a little goes a long way. There we go. Where do you find problems? These problems, because I'd like to practice. So these I just typed into Google optimization worksheets, and I find I use that. I find problems that I like and use them. Sometimes I'll use one of my books. So I have. Let me show you the books that I have that I use. So I have this book that I sometimes get problems out of. This is a calculus prep book. I have both. So I have both AB and BC of this. And then I also will use this book as well for some problems. What I like about this one is that it works it out step by step with you, but the thing I wish about this book is that it gave you some problems to try on your own. But it's good for these lives. And then sometimes I'll find worksheets on the internet. And again, use some of those problems. Good question, Joseph. Are they all university level? So remember that AP. So I usually like to use the AP curriculum, and the and remember AP kind of mimics a college class. So yeah. Sometimes though I'll also find university level stuff as well. But calculus is usually a university level course, so although I do offer it in high school. So yeah, let's move on to our next problem. So find two positive numbers. You could use ChatGPT too. The thing about ChatGPT is that it tends to get answers wrong. It tends to get questions wrong. In this, are we looking for relative max or absolute max? So we are looking. Yeah, I agree. I think ChatGPT is a I think it's a double-edged sword. I've seen it come up with really good questions, but I've also seen it when it tries to answer those questions, um, that it will just decide to just do some crazy math um that ends up getting it wrong. Sometimes watching ChatGPT do proofs is funny. But yeah, back to your question, XYZ. If in this, are we looking for a relative max or an absolute max? So usually when we talk about these, we're looking for relative maxes. The screen is cut off. Okay, Can you see it now? Perfect. Thank you, got your passport for letting me know that. All right, so find two positive numbers. Good, but okay, yeah. Let me fix that. Better. Awesome. No problem, Joseph. What about me? Thank me. Thank you, Gizmo. All right, so find two positive numbers such that the sum of the first and twice the second is 100 and their product is a maximum. So, first step. So, remember the first step to solving. I thought I did. I said that we were looking at relative maxes, but if I didn't, I apologize. So first step is that we're going to write down any relevant formulas. Thank you, got your passport for the follow. Oh, there is a shape. Thank you, Gizmo, for the follow. All right, so first, what do I know? I know that I have two positive numbers, so x and y are both going to be positive, such that the sum of the first and twice the second is 100. So I have x plus 2y is equal to 100. And I want to maximize their product, so I have x, y is a max. Yeah, exactly. So P of x, sure, we'll use P of x. So P of x equals xy, but remember, I want to narrow this down to one variable because that's my next step, to reduce to one variable if necessary. So what I'm going to do is I'm going to go ahead and solve this top equation for y. So I have 100 equals x plus 2y. So from here, if I solve for y, I'm going to first subtract x. I have 100 minus x equals 2y. And then I divide by 2. So I get y is equal to 100 minus x all over 2. So now I'm going to take this and I'm going to plug it in for y. So we can use p of x, sure. So p of x is equal to x plus this. So it's going to be 100 minus x all over 2. Now, I don't know about you, but I'm going to go ahead and reduce this a little bit more. So remember, if I have addition or subtraction in the numerator all over the same number, what I'm going to do is I'm going to split that up into two fractions. So why does p of x exist? P of x exists because that is what we are given. So what I'm going to do is I'm going to rewrite p of x as x plus 100 divided by 2 is 50 minus 1/2 x. And then because I have the same variable with the same exponent, I can actually combine those like terms. So I have p of x. Oh, no, you're right. You're right. Good catch. Good catch, Gizmo. So instead, I was going to go another direction, but thank you for catching me. So I'm going to go ahead and distribute the x here and here. So I have 50x minus 1/2 x squared. That's exactly right. That is exactly right. We're going to take the derivative next. So the derivative of p of x is p prime of x. What is the derivative of 50x minus 1/2 x squared? Let me go ahead and zoom in here so that way we can see it a little better. So what would the derivative of p of x be? Joseph says 50 minus x. Dick Barnett says 50 minus x. Yeah. So remember, use power rule. Take the 1, multiply by 50, and subtract 1 from the exponent. So that would be x to the 1 minus 1, which is 0. So x to the 0 is equal to 1. And then I do the same thing here. Take the 2, multiply by negative 1/2. So that's going to be negative 1 times x to the 1 minus 2 minus 1 is 1. So I would have 50 minus 1x, which I can rewrite. Thank you, Dick, for the follow. As 50 minus x. You haven't done derivative for 30 years? That's okay. That is perfectly fine. So what I'm going to do now is I'm going to go ahead and set my derivative equal to 0. Hey, have you done derivatives of logarithmic and inverse functions yet? Yep. I've already done those. So, again, you can find my past slides here. So now, hey, Imperfect, how's it going? Welcome on in. So what I'm going to do here is now I'm going to go ahead and set this equal to 0. So I have 50 minus x. If that's the case, then what would x equal? Why did I think there was a generic derivative formula? That's okay, Passport. Punk says 50. Gizmo says 50. Imperfect says 50. Yeah. So if 50 minus x is equal to 0, then x is going to equal 50. Right? Because I can add x to both sides. So now that is my critical point. So what I'm going to do now is I'm going to take the second derivative and I'm going to check its sign. Remembering that if it's positive, then it's going to be a minimum, but if it's negative, it's going to be a maximum. So I'm going to go ahead and take the second derivative, or the derivative of the derivative. So derivative p double prime of x. Let me move this up a little bit. That's exactly right, Imperfect. That is exactly right. The derivative is just going to be -1. So I do not need to plug in my critical point. Why? Because first off, well, there's nowhere to plug it in. And second, -1 is negative everywhere. So, because my second derivative is less than 0, that's right, Joseph, it's concave down, so this is a maximum. So this is a max. But it asks us to find both x and y. Thank you, Sammy, for the follow. So, since it asks us for both x and y, I now need to plug in 50 for x here and solve for y. So I have 50 plus 2y is equal to 100. If that's true, what would y equal? Gizmo says 25. Joseph says 25. Barnett of Duke says 25. Mine Yours says 25. Imperfect says 25. So yeah, we agree that y is equal to 25. Y. If I subtract 50 from both sides, I get 2y is equal to 50. 50 divided by 2 is 25. So that's it. Thank you, Mind Yours, for the follow. All right, so any questions on this problem? Thank you, K-Pow, for the follow. So I'm going to go ahead and call an audible here. I had one... Oh, actually, never mind. Thank you, Sarah, for sharing the live. Thank you, Sam, for sharing the live. The main structure of a derivative. So the derivative tells us what the derivative tells the story of the slope. So what I mean by that is that the derivative tells us the slope of the tangent line of the function. And remember that a tangent line only touches the function at one point. I am just working on gluing this next problem. There we go. I'm good on optimization, but bad at related rates. Okay. So, Amy, so I actually did 3 lives on related rates earlier. So, you can find them all right here. Because as soon as I am done with these lives, I download them and upload them here. I'll give you a second to take a screenshot of that. Then we will get going. So, let's go ahead and move on to our next example. is this. There we go. All right. Someone was mentioning the famous fence problems, and this is what we have. So the rest of the problems tonight are going to deal with fencing. So let's go ahead and get started. So a gardener wants to make a rectangular enclosure using a wall as one side and 120 meters of fencing for the other three sides. Find the value of x that gives the greatest area. So you'll see you will probably see either one of these problems, or sometimes the instead of a wall, it's a natural barrier, like a river or trees or stuff like that. So I'm going to go ahead and draw this, because sometimes drawing it is going to help us visualize what's going on. So this is my wall. And I know that the perimeter here on those three sides is going to be my fence. So how do I find perimeter of a rectangle? How do I find perimeter of a rectangle? How is that defined here? Let's see. So how do I find the perimeter of a rectangle? That is the question. Yeah, it's 2x plus 2y, right? It's the length of these two sides plus the lengths of these two sides. However, we don't have to worry about this side because it's a wall. So I don't have to actually worry about that. So to find the perimeter of this triangle, so P is going to equal, I'm going to call this X, and I'm going to call this Y. Why? Because I can. So P is equal to X plus 2Y. And then, remind me, how do I find the area again? That's right, Joseph. It's base times height. So area of a rectangle is equal to base times height, or in this case, x times y. So I'm given my perimeter. What's my perimeter? My perimeter is 120 meters. So that I'm going to set equal to 120. So now from here, I'm going to go ahead, because this is going to be the function that I take my derivative of. I need to go ahead and reduce this down to one variable. So I'm going to go ahead and solve for y. So let's go ahead and solve for y. There we go. So if I solve for y, so x plus 2y is equal to 120. What would y be? What would y equal? So this is constraint. This is our constraint. And this is what we want to maximize or minimize. So that's our constraint. Yeah, no problem. Thus says 120 minus x over 2 Gizmo says 120 minus x all over 2, or 60 minus x divided by 2. Yeah. So, remember, subtract x from both sides. So I get 2y equals 120 over x. Or, yeah, 120 over x. Let's try that again. 120 minus x. And then divide by 2. I get y is equal to 120 minus x over 2, which Gizmo's right. I can rewrite as 60 minus, I'm going to rewrite it as 1/2 x. If that's okay. Because negative x divided by 2 is the same as negative 1/2 times x. Plus, it's going to make the derivative a little easier for us to work with. This time, right? Thank you, David, for the follow. So what I'm going to do is, now that I've solved for y, I'm going to take this and I'm going to plug it into my area formula. So a is equal to x times 60 minus 1/2 x. Thank you, David, for the follow. So I'm going to go ahead and distribute the x. I get a is equal to 60x minus 1/2 x squared. Now that I have my area formula in terms of x, I am ready to take my derivative. So I'm going to use dAdx here. What would the derivative of that equal? I missed the first part of the question. Why do we need? No problem. So we want to maximize area given our perimeter. So in order to find the maximum, or to find the greatest area, I need to take the derivative of the area function. That is a good question, LG. Yeah, no problem. So yeah, Imperfect said 60 minus x. Joseph says 60 minus x. That's right. So here, I use power rule again. Take my 1. And there's the puzzle piece. So I have to take care of that quickly. Are we good? Yes, we're good. Perfect. So, here, take my 1, multiply by 60, so that's going to be 60 times x to the 1 minus 1, which is 0. Oops. There we go. And then, let me move the mouse out of the way. And then I take my 2, multiply by negative 1/2, so that's going to be minus 1 times x to the 2 minus 1, which is x. I'm going to get to that comment in just a moment, Sam A. So, now, I'm going to take my derivative and set it equal to 0. That's going to be 60 minus x. So now, if that is true, then what would x be? I just got a test on related rates and somehow I got a 100. Most of my... Congratulations, Sam A. Way to go! Way to go! You know what that means, right? Esmeralda says 60. LG said 60. Yeah, that's exactly right. So here, if 60 minus x is equal to 0, then x must equal 60. High five? Absolutely, Sam A. Ready? On 3, I'm going to give you a high five. And again, anyone that wants to join me in giving Sam A a high five, go ahead. On 3. Ready? 1, 2, 3. Thank you, Esmeralda, for the follow. There's a max because the second derivative is negative concave down. That's right. Thank you, Sammy, for the follow. So now, you divide by x to be it to 60 minus x. Nope. Because if I'm you divide. Yeah, no problem. No, don't be sorry. I was just having a little bit of, I was a little confused with the wording of the question, but I think I understand what you were saying. But yeah, no, we're not dividing by x. Not at all. Nope. So what we did was we took something called the derivative. So what we did was we essentially found the equation that gives us the slope of the tangent line of A. And then here, yeah, exactly. I add x to both sides. That's exactly right, Esmeralda. You're welcome. I love math. I'm glad to hear that. I don't know if you have your hand raised, Joseph, or if you're giving a high five. I'm going to assume that you're giving a high five. So yeah. So now to test whether this is a perfect. So yeah. So what I'm going to do is, in order to find whether this is a max or min, I'm going to take the second derivative of my function. So I'm going to go ahead and take the derivative of my derivative. So here, so d squared a over dx squared. That's right, imperfect. It's going to be negative 1. Why? 60 is a constant, and the derivative of a constant is equal to 0. So this is going to be 0 minus x to the first, or derivative of x to the first. So that's going to be take my 1, move it out front, and multiply by negative 1. So I have negative 1 times x to the 1 minus 1. 1 minus 1 is 0. So, and remember x is 0 is 1, so this is going to be my second derivative. Thank you, Sean, for the follow. Nope, not plus c because we're not integrating. If I were to go backwards, then yes, I would need a plus c. Yeah. No problem. I completely understand. So, here, because this is always negative, that means that 60 is a max. And what are we asked to find? We're asked to find the value of x that gives the greatest area. So we're done. So we are done. Cool. Any questions on that one? As I know I missed a couple comments, so I do apologize for that. How do you removable and non-removable discontinuities work in limits for functions? Remind me later to answer that question for you, but basically, removable discontinuities happen where there's a hole in the function, and non-removable discontinuities happen when I'm either jumping from one piece of a function to another, or when I have an asymptote. Can you explain shell method? So tonight I'm just focusing on nope. I don't actually need to find y because all we're asked is to find the value of x. We're not asked to find the area. Whoa, is this calculus? It is indeed. If it asked to find the area, then absolutely I would plug in 60 for y, solve for 60 for x, solve for y, and then find the area. Yeah, no problem, Joseph. All right, so can you explain shell method? So tonight I'm just gonna be focusing on optimization, but Shell method is definitely on my list of topics to go over. I need help with f of g of x, but with inverse functions. Okay, so if you want, Luke, feel free to send me a question. You can DM me a question, and I'll be happy to help you with it. Whoa, is this calculus? It is indeed, Blue Cat. It is indeed calculus. Wait, I clicked out for a second. Can you explain the last part with the second derivative? Sure. So, the second derivative helps us tell the concavity of a function, or which way a function is facing. So, it also tells us whether without having to plug in different numbers into the first derivative, whether a critical point is a minimum or maximum. And we can see that by this right here. So if the second derivative, by plugging in x, gives me a number greater than 0, it's a minimum, because when the second derivative is positive, my function's concave up. But if the second derivative is less than 0 at that point, then it's a maximum, because a negative second derivative is concave down. All right. Thank you, Seymour, for the follow. Thank you, Esmeralda, for the follow. Denominator area of fence is 60. Nope. So if we were to find the area of... So 60 is just the length of this side x. In order to find the area, I need to find the side of y and multiply my x and y. I'm a freshman engineer. That's awesome, Luke. That's really cool. Well, thanks for explaining. You're welcome, LG, and thank you for the follow. And thank you, Ryan, for sharing the live. That's right. Length times width, or base times height, is the area of a rectangle. That's right. That is absolutely right, Susie. Cool. Let's go ahead and do a couple more. And then we will call it a night. Thanks for You're welcome, Sarah. You're absolutely welcome. I'm happy to do this. I'm always happy to show the world calculus and other math. So, let me go ahead and turn the page, because I have no more room on that other page. So, which one do I want to do first? Let's do this one. So I'm just going to apply the glue. There we go. What's the highest level of math that I teach? Would I do calculus 2 or 3 ever? Yep. So, I'll actually show you that in a moment. Let me just make sure this is on the page first. Perfect. So, here is a list of everything that I currently tutor. Does that mean that list isn't going to grow? Nope. It can grow, but those are the subjects that I currently tutor. I do. I do, Blue Cat. Do indeed. Super cool. You seem like a really nice guy. Thanks for fun. You're welcome, LG. Thank you for that. I definitely try to be. But thank you for that. Am I familiar with CLEP, like pre-calc? Let me take a look. I am not, but I should definitely look into it because I'm just doing a quick look here, and it's nothing that I wouldn't be able to do. Yeah, no, I can do that. What about trig? Yep. So when I include trig in pre-calculus, but yes, I do tutor trig as well. Although I usually lump it into pre-calculus. But absolutely, I can go over trig. Thank you, Blue Cat. Thank you so much. All right, so suppose you had 102 meters of fencing to make two side-by-side rectangular enclosures. What is the maximum area you could enclose? All right, so I'm going to go ahead and draw this. Let's go ahead and draw. And I forgot to warn everybody that I can't draw, so I apologize in advance for awful drawings. Because art was not my best subject. All right, so we have 102 meters of fencing. So, in order to find my perimeter, what I'm going to do is first I have to take these. So I'm going to call this side Y. I'm going to call this side X. Or actually, should I call this whole side X? No, I'll just call it that. So here, because I have 102 meters of fencing to make two side-by-side rectangular enclosures, so that means that my perimeter, if this single side is X and this side is Y, my perimeter is going to be what? It's going to be 1, 2, 3Y plus 1, 2, 3, 4X. And we're given that the area, the perimeter is 102. So now I want to find the area of this rectangle because we're sharing a fence here. So area, remember area is length times width for base times height. So here it's going to be 2x times y. This looks familiar? Okay. So here we go. So first, I've written down my formulas. Now I'm going to reduce my area formula down to one variable. So here, I'm going to solve this formula for x. So I have 3x plus 4y is equal to 102. Solving for y, if I subtract 3x from both sides, get 4y equals 102 minus 3x. Divide both sides by 4. Thank you, Blue Cat, for the follow. And I get y equals 102 minus 3x all over 4. So now I'm going to take this and I'm going to plug it into my y here. So I have area is equal to 2x times 102 minus 3x all over 4. Next question is this. What do you see? What do we see in this formula that I can do? Laney says reduce. Yep, that's exactly right. I could distribute the 2x, but I'm going to actually wait to do that for a second because I can reduce this 2 and this 4. So here, 2 goes into 2 once, and 4 goes into 2 twice. So instead of 2x times all of this, area is going to equal x times. Now, I'm going to go ahead and simplify this fraction a little bit. 102 divided by 2 is 51. And this is going to be minus 3/2 x. So now, Lexi, I'll go ahead and distribute the x. I get area is equal to 51x minus 3/2 x squared. So now that I have my area in terms of x, I'm ready to take the derivative of the area function. So, dA dx is going to equal what? What will dA dx equal? Jeff says 51 minus 3x. Do we have any agreement? In the future says yes. Yeah, that's exactly right. So here, I'm going to use power rule again. Take the 1, multiply by 51, so that's going to be 51, times x to the 1 minus 1 is 0. And then, and remember x to the 0 is 1. So I'm just going to leave that as 51. Then I take my 2, multiply by negative 3/2, so the 2's are going to cancel, so that's going to be 3x. To 2 minus 1 is 1. And now that I have my derivative function, I'm going to go ahead and set it equal to 0. 51 minus 3x. So, if that's the case, then what would x equal? Shadow says 51 over 3. Jeff says 51 over 3. That's right. Can you reduce that, though? Jay says 17. Mia says 17. Yeah. In the future says 17. Yeah. So here, add 3x to both sides. I get 3x equals 51. Divide both sides by 3, not x. And I get x is equal to 17. So now, is x equals 17 a maximum or a minimum? Thank you, username, for the follow. Is x equals 17 a max or a min? Child says minimum. Mia says maximum. Imperfect says minimum. Thank you, Salmon, for the follow. Sarah says minimum. Let's find out. So to find whether this is going to be a max or min, I'm going to take the second derivative and plug in 17 for x. So if I take the second derivative, which is just the derivative of the derivative of 51. Well, 51's a constant, and remember that the derivative of a constant is 0. So this is going to be 0 minus 3 times x. So I'm going to remember variable without an exponent is the same as variable raised to the first power. So I'm going to take my 1, multiply by negative 3, so I get negative 3. X to the 1 minus 1 is x to the 0, and x to the 0 is 1. It's almost 1:20. I got to go to sleep. Good luck. Thank you for joining us tonight, Luke. Have a great rest of your evening. Or should I say morning, because like you, it is also 1:20 over here on the East Coast. So, that's okay. Don't be sorry about that. Don't be sorry at all. So because the second derivative is negative, I have a maximum. I just found you and you're amazing, bro. Thank you, David. I'm really happy to hear that. I'm really happy to hear that. I definitely try to put on a good show. So we know, because of this, 17 is a max. But we weren't asked to find the length of x. No, we were asked to find the maximum area. So now I need to solve for y. So what I'm going to do is I'm going to plug in 17 everywhere I see an x in the perimeter formula, solve for y, and then I'm going to find my area. So I have 3y plus 4 times 17 is equal to 102. If y is negative, then we did something wrong. So 4 times 17 is the same as 34 times 2, which is 68. So 3y plus 68 equals 102. If that's the case, then what must y equal? If 3y plus 68 equals 102, what is y going to be? So Happy says 11.3 repeating. Shadow says 34 over 3. Yeah, that's exactly right. So, right, why? Because if I subtract 68 from both sides, I'm going to have 3y is equal to 34. 34 divided by 3 gives me y. I'm going to keep it in fraction form because I can. And now my final question is the area. So now that I have my x and my y, I'm going to plug it into my area formula. So I have 2. So 2 times 17 times 34 over 3 is equal to my area. 2 times 17 is 34. And 34 times 34 over 3 is going to get me I get A equals 385.3 repeating. And what's my unit? My unit is meters squared. Any questions on that one? Any questions at all? So, I'll go ahead and leave that up for a moment while I go ahead and put the glue on my final problem. And speaking of it, which is time for the final problem. So, to unlock, so there are 22 of us in here. In order to unlock the final problem, let's see if we can't get to 4K likes. Let's do a quick mad tap to 4K. So hopefully everyone's having a good time with this tonight. Yeah. So yeah. Now we are down to our final problem. I find optimizations and related rates to be tricky in Calc 1. Absolutely agree. Absolutely. In fact, those are two of the hardest parts of Calc 1. A lot of students really struggle with them. Eugene values. Find a use for eigenvalues. I'm sure you could find a use. If you type into Google real world applications of eigenvalues, I'm sure you'll find some. With related rates, I think it just takes practice problems, but I'm not sure about optimization. Same. Absolutely. And here's the thing: I don't think it's necessarily the math that people struggle with. I think it's breaking down the word problem into something manageable and something able to convert from English to math. Or at least that's my thought on that. So yeah. So as soon as we get to 4K likes, we will go ahead and start the final problem. Thanks a lot. You give us your precious time for teaching. You're welcome, Sarah. As I said, I'm happy to do this. Um I think it I think math overall gets a bad reputation, and I don't think it's the actual subject's fault. I think it's how we were taught it. Because let's be honest, um I find that a lot of people, once they understand the logic behind math, they're like, "Oh, that wasn't horrible at all." I mean, to me, math is like finding like solving a puzzle, like a crossword puzzle or a Sudoku puzzle. But it's like solving a puzzle, and as soon as you solve that puzzle, we're like, "Yes, I did that," and that's something worth being proud of. And I think the big thing is that sometimes we're forced to rush into finding answers instead of really taking time to understand the problems as we're working on them and to really slow down. Do you have a favorite math? Calculus is my favorite to teach. Um, but my favorite math right now is this thing called abstract algebra. I find that really fun. It's been a while since I've done it, so I don't include it on my list. But I really did enjoy doing. I really did enjoy that class. For ninth grade, it's good way as parents to learn to help. Agreed. Absolutely agree. Yes, I remember being taught differently on how they are teaching my third grade son. Yeah, and that's the thing, right? We're making. I personally think, and this is my own philosophy on math, but I think right now we're overcomplicating things and making solving these basic problems more complicated than it has to be. Abstract algebra is cool. I agree. And the way my teacher, when I was in college, the way my professor taught it was a proof based class. So basically, he would give us just enough information to solve the proofs, and the rest of the class we would just be working on proofs and listening to other people do proofs. Yes, because math has different ways. Absolutely, I agree. I fully agree with that. I tell my students all the time, there's 1,000 ways. As long as we all get to the right answer, I don't care how you do it. The way I do, I've been tutoring calculus for almost a little over a decade now, and I've been shown processes of solving problems that work that I would have never considered because that's just not where I would be thinking. But as long as we all arrive at the right answer legally, then I don't care how you got there. All I care about is that we get to the same destination. And sometimes I like that I've been tutoring now for um close to 20 years, and um I still learn stuff. Thank you, thank you, memes, for the follow. I love to learn in USA ways and use ways, teaching ways to help my kids after my ways to solve. Yeah, definitely. All right. So here's the final problem. Now that we've reached 4K likes, thank you all for the likes. Suppose you had to use exactly two. Yep, this is optimization. That is absolutely right. Suppose you had to use exactly 200 meters of fencing to make either one square enclosure or two separate square enclosures of any size you wished. What plan would give the greatest area? Hey, Null, how's it going? I'm doing pretty well. How about yourself? So, here we go. So we're asked whether the greatest area comes from one square enclosure or two separate square enclosures. So here's how we're going to do this. So first, let's go ahead and find one square enclosure. Let's suppose this. Now, the thing about a square is that the perimeter and area are gonna formulas are going to involve one variable. Instead of x and y, we use length and width. No, yeah, I just use x and y as variables, but it's the same thing. Yeah. So with a square, we know that squares, all four sides are congruent. So x equals y. That's right. So I only need one side. So here, my perimeter is equal to 4x, and my area is equal to x squared. Now, do I actually need to do I actually need to do I need to find the critical point here? Well, if 4x is equal to 200, what must x equal? X equals 50, right. That's right now. That's right, Esmeralda. That's right, Imperfect. So the area of this square enclosure would be 50 squared. And 50 squared is just 5 squared with 2 zeros. So here, 5 squared is 25. Whenever I have a 0 all squared, I just double the number of zeros. So that's going to be 0, 0. So the area of the square enclosure is going to be 2,500. So now let's find the rectangles. So it doesn't say that they're together. Oh no, we have two square enclosures, not rectangle. So now I have x here. So perimeter is going to equal x times x plus x minus x plus x. So that's going to be 4x. Plus another one. So that's going to be plus another 4x. Right? Because with squares again, the perimeter is just going to be 4 times the side length. That's going to be 8x. And then its area is going to be 2 times x squared, right? Because area of a square is x squared, and there are 2 of them. So that means that I have 2x squared. Actually, we didn't even need optimization for this one. Why? Because if 8x equals 200, what must x be? Miyamo Hefe says 25. Now says 25. Yeah. So x equals 25. You're right. They are 2 different squares, but it turns out that that's not going to matter. That's right, Miyamo Hefe. So if I plug in 25 for x, I get 2 times 25 squared. 25 squared is 625 times 2 is 1,250. Oh, and my unit is square meters. So, which one gives me the greater area? Which one of these? Is it 2 squares or is it 1 square? Yeah, it's going to be 1 bigger square, right? That's right. So with that, I'm going to go ahead and call it a night. But don't worry, I have more really more optimization problems that we're going to work on tomorrow. You need to do different size to find maximum possible area for 2 squares. Yeah, so if I do that, it turns out my answer is still the same, but I can prove that to be the case. So let's say that this first square is x by x, and this second one is y by y. So you are right, Ahmed. I need to prove that. So I have perimeter is equal to 4x plus 4y. My area is equal to x squared times y squared. No, plus y squared. Yeah, plus y squared. So here's my constraint. Solving for y, I get this. I get, so 200 minus 4x equals 4y. Divide both sides by 4. I get 200 divided by 4 is 50. And 4x divided by, negative 4x divided by 4 is x. And that's going to equal y. So now I'm going to plug that in to y squared. So I have a is equal to x squared times 50 minus x. Now I distribute on both sides, on both terms, so I have a is equal to 50x squared minus x cubed. No, you're right. You're right. Yet I'm adding that x squared, right? So area would equal x squared plus 50 minus x all squared. So this would be x squared. 50 times 50 is 2500 minus 100x plus x squared. Can I help with carbon dating? It has been a long time since I've done that. But there's a there's a person here on TikTok, Professor TK the chemist. She could help. I'm sure she can help you with that. Because I'm not very good at chemistry. So now here, this is going to be a equals 2x squared minus 100x plus 2500. I can help you with differential equations though, yes. So now let's take the derivative. So I have dA dx is equal to take my 2, multiply by 2, so that's going to be 4x. So 2 minus 1 is 1. And then remember, a variable of our next one is the same as variable raised to the first. So I take my 1, multiply by negative 100, so that's going to be negative 100 times x to the 1 minus 1, which is 0. And then the derivative of 2500, since that's a constant, its derivative is going to equal 0. So now I set my derivative equal to 0. So I have 0 equals 4x minus 100. Yeah. So I have x equals 25. And then by taking the second derivative is going to be derivative of 4x minus 100. Well, that's going to be 4. So that would be a minimum. That would be a minimum. So d squared a over dx squared is equal to 4. And because f double prime of x is greater than 0, that's a minimum. So that means this will actually give me the smallest area. So is minimum. Oh yeah, no, I appreciate Ahmed. I do need to prove that. But it turns out it is the same. In this case. Sometimes it's not. So with that, now I'm going to go ahead and call it a night. But before I go, we did use calculus, that's right. And that's the point, right? That is absolutely the point. So, before I go, I do want to plug a few things. So, where did my, oh, here it is. So, as I said before, I download all my lives, and they will be uploaded here on this channel. So if you go here is the set of all actions that you should take when you get to that channel. And then, if you want to follow me on TikTok, you can follow me at Robert the AP Math Guy, but not DX. Don't add DX. Just Robert the AP Math Guy. So here, now I'm going to go ahead and recommend a couple other people that I highly recommend you should follow. First, you should definitely follow ACG Math Tutoring. So she helps people get ready for their ASVAB, their Accuplacer, their GED, their TEAS tests, and as well with algebra and geometry. In fact, Audrey at ACG Math Tutoring was the one who convinced me to join TikTok in the first place. So, if it weren't for her, I wouldn't be here right now. So I would definitely give her a follow. Also, I highly recommend you follow Learning with Lynette. She's actually live right now. Thank you, Pablo, for the subscription. But yeah, she does really well. She does a really good job teaching people about the abacus. So as soon as I'm done with this live, if she's still live, I will be jumping into her live. So if you want to join me there, if you do join me there, tell her Robert sent you. Do I teach algorithm? In what form? And then, here, so as I said before, I am an online math tutor, and I offer tutoring for both groups and one-on-one. So for group tutoring, I offer tutoring to groups of 3 to 10 students per group who are all taking the same class at the same time. Now, that doesn't necessarily mean that you have to be taking it with the same teacher or even at the same school, but what it does mean is that you all have to be taking the same class. So, for example, let's say you and 6 of your friends are all taking Algebra 1. Then I can help you. You can sign up for group tutoring. And for the 2025-26 school year, I charge $35 per hour per person. And then I also offer one-on-one tutoring, but those rates are based on how often you want to meet and how long you want each session to be. So if you're interested in either one of those, feel free to DM me here on TikTok, and we'll schedule a free consultation. Do you guys do Integrated Math 3 Pathway? I'm not sure what that is. If I'll look it up. I'm not quite sure what Integrated Math 3 is, but let me take a look quickly. Quickly. But it may just be a different name for the same thing. Oh, yeah, absolutely. Absolutely, I do. Have a good night, Sarah. Hey, Brandy, you can call me Robert. Hey, Robert, I have a question. How come many people find linear algebra hard? I think for me, I had to self-teach it because I didn't take a formal linear algebra class in college because I was student teaching. But I think the reason why I don't think it's necessarily hard as it can be overwhelming at times, because when you have a matrix like 20 by 20 and you're asked to find the value of each value of each term, it gets overwhelming, and I think that overwhelm is why people find it so hard. Because once you learn the algorithms, it's not really that bad. All it is just I think it's more of the overwhelm of working with larger matrices. That's just my personal opinion. So yeah. So with that, I'm going to go ahead and call it a night. Let me go ahead and see if I need to stay on a little longer to earn some rewards. Nope. Have a good night now. Lol, my Calc 3 professor jokingly said if anyone solves a hard matrix linear algebra problem, he'll give everyone an A. Awesome! Fair enough. Alrighty then. Have a great rest of your evening, everyone. Like I said, I'm going to be jumping into Learning with Lynette's live, so she is still live, which it looks like she is. I will see you there. Otherwise, have a great rest of your evening, everyone. Bye now.